Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back to finalize the build, or at least the main components of our 6C33C build, and kind of the overarching design that we're going to do. I know I've been jumping all over the place, and honestly that's kind of the process that I go through when I'm building one of these things off of someone else's initial design. I mean, I was really gravitated to DHT Rob's design because it was simple. It's got one triode strapped input tube and then the output tube, and that kind of follows my design philosophy that you don't have a bunch of stages with phase inversions and the inversions getting out of phase slightly where they're not exactly 180 degrees. The more inversions you have, the more issues you could have with distortion, and they just don't sound as clean. So I really like this design, but there's a few things that I'm going to change after looking over everything and doing some more reading. I know I was jumping back and forth between fixed bias and cathode bias, and there's plus and minuses with both, and don't want to give a spoiler because then you won't watch the rest of the video. So let's jump into what we're going to be doing. Okay, so been looking at this and thinking more about this tube, the setup, the heat, the powering up the heaters and all of that stuff, and I think I've got a plan now. One of the things I noticed is you can run this tube with just one of the heaters powered up, which basically makes it running with one cathode. And when you look at the dissipation here, you can run it at 45 watts or 75% of its power just running one heater. By doing that, I'm going to assume here that when you look at the heater voltages, you can run them in parallel at 6.3 volts. When you are running them in parallel, you get, says somewhere between 5.6 and basically 7 amps. Well, I'm hopefully going to assume that that means if you're just running one of them, it's half of that. So you would have 3.5 amps to run the heater, and that's got to make the tube run a whole lot cooler, having 3.5 amps instead of 7 amps going through it. Also makes it within the realm of being able to run it off of the 6.3 volt winding of this transformer we're looking at. After looking at the plate curves, I think we need to limit the plate voltage to 200 volts. And that gets into some weird stuff if I try to use it as a fixed bias as far as coming up with a transformer that ends up with that voltage that has all the windings we want. So I think I'm going to do it with a cathode bias. I know it's going to put some extra heat coming off of that cathode resistor, probably going to make the amp safer to operate, and you don't have to worry about setting the bias on it regularly. And I still think we're going to get some really good power out of it if I design it correctly and set the bias point and the plate voltage in a good spot. So, having said all of that, and again, we can run it at 45 watts, and here's the grid resistance. It says 200K, so it looks like we'll be fine running that 180K resistor on the grid, which will make it easier to drive the tube with the front end we're trying to use as well. That's the other concern, is if I go to fixed bias, I'm reading people saying you need to keep this under 100K, which is just going to make it much harder on the driver tube to drive this grid. And so I think cathode bias is going to be the trick here. So now that we're done looking at this, and like you said, you can look at this diagram here. If you just do one heater, it just heats up this side of the cathode. And the other neat thing we can do is 1 amp I can wire it up using pins 1 and 2. And then on the other amp I can wire it up using pins 6 and 7. So as the tube ages, we can swap the tubes from 1 amp to the other and just use up the other side of the cathode. So it should extend the life of the tubes. So I'm going to show you my understanding of drawing output tube load lines. So if we look at the plate curves, if you think about the DC load line, it's going to be vertical. There's so little resistance in the output transformers, like 45 ohms. It's basically nothing. So the load line would just go straight up at 200 volts. And I'm going to show you how I draw the AC load line, which is where we set the bias point from. So we come over to our handy dandy Ohm's law calculator. We got 200 volts. We take the impedance of the output transformer, which is 600 ohms, and we calculate, and we get 333 milliamps would be the maximum current that would be going through this in AC. Okay, so we're going to look at the AC load line on this chart now that we know what the milliamps is going to be. 330 milliamps, 200 volts, 330 milliamps, 200 volts. This chart is for both cathodes powered, and this chart is for one cathode power, which is what I want to try to do. So we look at the intersection of 200 volts, and we're shooting for 200 milliamps. And so we want to draw a new AC load line moved up in this direction so it intersects that point. So we get that one on this chart and that one on this chart. And you can see here that we have the intersection of 200 milliamps and 200 volts. And then on this chart over here, we want to do the same thing. We want to have the intersection of 200 milliamps and 200 volts. So this is going to be our bias point if we run one cathode, and to get that same current at 200 volts, this would be the bias point. And so you can see the numbers on like this side. So that's -2, that's 10, 20, 30, 40, 50, 60, 70. You'd need -70 volts of bias or voltage on the cathode with both filaments powered up to get at 200 milliamps running 200 volts on the plate or across the tube. And again, I mentioned that in the last video. You don't measure from the plate to ground when you're doing a cathode biased amp. You measure from the plate to the cathode. And we're shooting for 200 volts. So over here, you can see to get to that same bias point of 200 milliamps at 200 volts, instead of 70, we're looking for about 58 volts, which honestly is going to make the amp a lot easier to drive. And it makes sense that if you have both cathodes boiling electrons, that it's going to take more negative bias to hold the milliamps down to 200 milliamps than it will if you're only using one of the cathodes. And as you can see, we can get the same bias point and basically the same power out of the amp running just one cathode on this AC load line. And yeah, it's closer to the maximum, but I'm okay with that because it's going to massively simplify the amp if we only run one cathode, and it's going to make the tube run a ton cooler. Plus, now we only have negative 58 volts on the grid instead of negative 70. So then the swing that the driver tube needs to create is only about 110 volts instead of 140 volts. So it's going to make it a lot easier for this driver tube to get the voltage swing we need to make the tube get to max power. So I hope that makes sense. This was very confusing to me to start with, trying to figure out like what people were doing or what was going on here. But I've kind of figured out this thing of creating the AC load line based off the impedance of the output transformer versus the voltage, and then you just kind of draw parallel load lines out to wherever you want to set the bias point to. Now we could bias this at negative 70 volts or put 70 volts on the cathode and have 170 milliamps and pull this load line in this direction a little bit from this curve to bias it a little cooler. And that's what's happening when you bias it cooler. It's moving this line further away from this max power curve line here. But I still think we're going to be fine biasing at this point. So let's go over here and look at our tube bias calculation. And it says we can run that tube up to 45 watts. So if we plug the numbers into our calculator here, using a 42 watt tube, 200 volts, calculate 200 milliamps, we're at 95% of the tube. Which, yeah, that's pushing it pretty hard. But again, we're down rating the tube to a 42 watt, so I think it'll live there. And hey, you know, till you try it, you don't know. That's running 40 watts on the tube of 45 watts, so we're leaving 5 watts of headroom. I'm comfortable trying that. Got to start somewhere. So then we come over here to our transformer that we were talking about using in the last video. And that's that 450 volt. It's this one right here, this 369KX. It's got 450 volt center tapped, 300 milliamps, and that's calculated using a full wave rectifier. We're not going to use this 5 volt center tap, and for now we're not going to use this 50 volt tap either. But here's the interesting thing. This thing has a 6.3 volt, 6 amp secondary winding. Remember, we only need 3.5 amps at most, or 3.6 amps to power up one side of this tube. And that means we don't have to add another transformer here to power up the heater on the tube. We can pull it off of this, and there's still enough amperage left to do the input tube heater. So that keeps us from having to add another transformer inside the amp, which is a good thing. Saves us some money there. So the last thing we want to look at is I did some more PSUD2 calculations. We got our 37 ohms on the transformer, 225 volts. Remember, we did this single choke with a 220 UF and a 470 UF, and when we simulate it, we get 270 volts on the output. Now, if we need to dial this down some, we have a couple of options. We could toss another choke in here that has a little bit of resistance, and that would chill out the B plus some. And you can see we got super clean output here. We're out to 3 digits before we see any change. It's like 0.004 ripple, which is just nothing. But again, if we needed to kill off some of this voltage, we could either drop this capacitor down to, we could toss one of our little 22 UF Solene caps in here, and that drops us down about 6 volts, and we still got pretty clean ripple here. I mean, it definitely has more than it did before, but probably a better solution would be to drop another choke in here. And let's look real quick, see what Hammond has that we could toss a little resistance in here. Get one of these we can drop inside here. We obviously want to get like a 300 milliamp. Even a 250 though would be okay. But let's see what dropping a 2.5 Henry 300 milliamp choke, putting 43 ohms of resistance in here does. This is 2.5. There we go. That knocks almost 10 volts off. So if we end up with a little bit higher voltage than we want to see, we can drop this down, add another choke and another cap in there. So you can see, adding some DC resistance here, we can get the voltage down if we need to. So like I was saying, between some of these options, like here's another thing we could probably do, is drop this first capacitor when we add the second choke, and that gets us down to 256, and got a super clean power supply there. So we may end up doing that. I may end up just buying some combinations of this stuff to dial in the voltage on the plate, and then you won't have to. I'll get to figure that out for you in the real circuit, what it ends up being. So the other thing that we need to look at is figuring out what kind of cathode resistor we want to use. And so we know we want to get about 58 volts. And we're going to be right at 200 milliamps. So let's see what cathode resistor we need to get. And somewhere around 290 to 300 ohms, somewhere around in there will work good. I think that's where I'm going to go. I know I've been bouncing around all over the place with this build, but now that I'm looking at these curves and then thinking about the heat coming off the tube, and I've read too people saying that the single triode actually sounds better. And if you look at the curves again along this load line, while this doesn't look bad as far as the spacing between the grid voltages versus the load line, this does look more linear to me. And so I think that's what we're going to do. So I'm going to get some of these parts ordered. I'm going to maybe do just a little more math and think about this some more, but I'm pretty sure that this is the direction we're going to be going. I'm going to look on the Mauser website, see like what's available as far as some of these power resistors and stuff, and try to get an order in tomorrow afternoon and get some parts coming. But now I'm at the point where I'm going to do a cathode resistor, and I'm going to use this 269KX transformer. So yeah, let me do a little more research, but I'm pretty sure I'm in a good spot now of where this is going, and I think this is going to work out really good. It's starting to make some sense with at least the parts that are readily available. Okay, so now we're going to do the chassis layout and figuring out what size chassis we need. And I want to try to build these as compact as possible and use a regular production Hammond chassis as the base for the project to try to keep the cost reasonable. The other thing, we had talked about using these 193H inductors or chokes in the power supply, and still not sure yet whether I'm going to need one or two of them to get the B plus voltage or the plate voltage where it needs to be. I'm hoping I can get away with a single choke, but anyway, I was kind of running out of room on the top of the chassis, and the other issue was this is a 200 milliamp 5 Henry choke. You can see right there where it's got the specs on it. And I saw that they have an open frame choke that is this size, which is a pretty big beast, but they have these in a 4 Henry 230 milliamp choke, or maybe it's 225, but it's this size choke that I can put inside the chassis. And so I think this is what I'm going to go with. And to use them, I have this size chassis, but it's a 2-inch thick one, and I'm going to need a 3-inch thick one to use that choke and be able to put it inside, because it's fairly tall. It's about 2.5 inches tall. So if I go with the 3-inch tall one, these can get mounted inside the chassis, like here or somewhere in the chassis underneath. So that frees up some room on the top deck. So I think this 8x12 is going to be large enough to pull our parts on. So what I'm thinking about doing is putting the power transformer, which will be about this size. It's not going to be this 274BX, but it's going to be similar in size. It's a little bit thicker, but it's basically the same footprint. It can sit over here in this corner. Now, this is a beast, and we could put it right here, but I really don't like it being this close to the power transformer. I think that's just asking to pick up noise. And we do have some room up here, so I'm thinking about shifting this forward like this and getting it away from this power transformer, or at least having the laminations not directly in line with each other. So then we can take this little 193 choke, put it up here in front, and then on the underside we can mount this guy kind of back here. Then if we have to add another one, we could put one sideways like this, or maybe underneath the power transformer, or underneath this other choke in this area. But we'll see. Hopefully we can get away with just one of them and get the B plus in a reasonable range. So then we have the tubes and the other parts that we're going to go on the top of the amp. So the output tube can go up here in the front, kind of up here in this corner. Keep it away from everything, and we're going to mount the socket on top of the chassis, and we're going to space it up off the chassis with some Teflon spacers so the air can circulate up underneath it and not have the heat from this tube going on the inside of the chassis. Since we're going with a cathode bias, decided I'm going to put the cathode resistor back here on top of the chassis. So the input tube will sit here, and then the cathode resistor can sit kind of like, we'll use this little tube box as a placeholder, but it can sit like that in front of this choke over here, so we don't have the heat near the tube. I mean, I could put it right behind the tube, but I think there's already going to be a lot of heat over on this side, so put the cathode resistor like that. Makes sense to me. And then put the input tube up here out front by itself. And then the second monoblock will be the mirror of this, with the input tube like here. So we would have, then the input tube, and then the output tube would be like way over there, away from this one. And keep those spaced as far away from each other as we can. Then we'll have the power transformers next to each other. We'll have the output transformers on the outboard here. And then we could do the speaker jacks like in the side underneath the output transformer. Over here. Like this. Or we could put it in the back. I mean, the back's kind of the normal place to put it. I just have to think about how much AC current and stuff we're going to have back here, if I want the speaker jacks going back there or just have them into the side. And then for the input jack, I'm probably going to do like I've done on my other monoblocks and just put it like right here, right next to the input tube. And just have it, you know, a super short distance. There'll be some tag strips that are going to attach to this tube socket that are, you know, putting the parts that support this driver tube attached to, and then I'll figure out where I want to put the input jack. The other option would be to put it in the front. There's a lot of amps that do that. I know some people hate having the cables exposed and they want to have them all hidden in the back so they're neat. Yeah, I'm more about function rather than appearance. So I design my stuff where form follows function. And so, anyway, this is probably the layout that we're going to be using. And I know the iron's all kind of cramped up here in the back, but I do think that having these turned this way, like this and like that, and having this one sitting here, we're not going to have electrical interference between any of this. And luckily these have an indirect heater, so we don't have any worries about, you know, having to come up with DC heaters or anything like that. I think this will work, so I'm going to order a couple of 8 by 12 by 3 inch chassis to use with this build. I'm going to order several of these chokes. I think I'm going to get about 4 of them because that's kind of a nice size to use on a lot of builds. And then get the power transformers ordered, and hopefully can have that stuff here in a week or so and can get going on this build. Well, as you can see, we finally got this distilled down to getting the parts ordered. And I'm happy with where this is right now. Got a secret here on my little driver tube. We're going to save that for the next video. I'll give you a little spoiler. Here's what we're going to be using. It's the only thing that I could find that was even close to a D3A. And I've read people saying they have problems with these being microphonic or some other issues. Can't imagine that D3A tube doesn't have the same issues. Maybe they don't. But I can't in good faith put together what I'm calling a budget amplifier and have a driver tube that sells between $180 and $300 or whatever people are getting for them on eBay. It's just ridiculous. And so, yeah, it would be nice if there was some new production tube that we could use. There's really not. I mean, there's ways to use other pentodes, but I don't think they're going to have the drive and what we're looking for that this one does. And so, that's what we're going to try. Again, we're using a ceramic socket. I did find, like I said, some 4 Henry, 225 milliamp chokes, and here's the number for those. Hopefully I can get by with one of them, but if I need 2 of them, I don't know. Historically, I've run 2 chokes in most of my amps, and so we're probably going to end up running 2 chokes. And I know that that 22 UF Solene film cap sounds great in amplifiers, but again, I'm trying to get it to fit in this smaller chassis. It is going to be thicker than this. It's going to be the 3 inch instead of the 2 inch 8 by 12. So I'm going to get a pair of those ordered. I'm going to get the rest of this iron ordered, and then yeah, we can start building this thing. So it's probably going to be about a week or so for those parts to get here, so there may be a little break here, which I kind of need to go build some production amps anyway. And so don't think that I've dropped this whole project. I haven't. I just got to wait for the parts to get here. And so I think this is going to be a really cool amp. Even if we're only using half of this tube, it's still a 45 watt dissipation triode, which is going to destroy a 300B as far as power wise, or it should. And I've heard they sound really good when you do limit it to just driving one side. And then, like I said earlier, I can build this so that you can swap the tubes from one channel to the other to double their life. So that's a cool thing. And it's going to put out a lot less heat than these things are notorious for. So, anyway, I'm happy with the way this is turning out. And I hope this makes sense to you guys. And again, I want to thank Chris for catching my little error on the, actually it was a big error, on the transformer and not calculating in that multiplication factor for using a bridge rectifier. If you guys see me doing something goofy like that, please send me an email because, again, I want to put out accurate information, or as accurate as I can, and also I don't want to build something that's not going to work or overheats or smoke comes out of it. I mean, that's not helping anybody. So thanks again, Chris, for the kind way that you reminded me about that, and hopefully we can get going on this in the next couple of weeks. So thanks to you folks who have been watching these videos. Excited to be building something new. Hopefully that I got that load line thing right. I'm still trying to wrap my head around the whole drawing load lines for output tubes driving a transformer and with inductance and a reactive load instead of a resistive load and all that stuff. It's still, yeah, I'm trying to just get the core understanding of that, but I think I'm starting to grasp how that works and how that relates to especially this build. So yeah, hopefully that's helped y'all kind of understand it too. Thanks you folks that have been viewing my videos, subscribing if you like the channel and like this content. There's a bell if you want to get notifications on my new videos. Thanks to you Patreon folks. Thanks to you folks that are making donations to my website. I got a couple of them last week that are probably related to helping with this build. And I'm probably going to put these monoblocks up for sale to just kind of recoup the cost of the price. Unless they really sound good, I may keep them, but we'll see. Anyway, hopefully we'll have some more content next week or maybe the week after. We'll see how the parts ordering comes. And until next time, have a nice day.